For these review questions, it will help if you have a sheet of graph paper. So in a moment, I'm going to ask that you pause the video, get a sheet of graph paper, and also graph each of the ordered pairs that are in this table. As you graph the ordered pairs, make sure that you label the x and y axis, and also give the graph a title. Pause the video now and make the scatter plot. Hopefully your graph looks something like mine. Notice that I have age and height labeled, and there's also a title at the top. Now that the dots are graphed, we want to connect them, or we want to make a line of best fit. We don't want to connect the dots like a dot to dot. We want to make one line that goes all through the dots and hopefully hits a few of them, but if it's going to miss the dots, we want it to miss just as many dots above the line as below the line. That line would not be a good line of best fit because all of the dots that it misses are below the line. This would be a little bit better, and that one looks better still. It hits a few of the dots that were graphed on the line. It looks like it misses about the same number of dots above as below the line. Now that we have that line of best fit drawn in, we can try to write an equation for the graph. Whenever we write an equation, we want to write it in y equals mx plus b form, where the m is the slope and the b is the y-intercept, or the beginning point of the graph. We can find the beginning point of the graph by looking at where the graph hits the y-axis. So when you made your line, hopefully you made it go all the way back so that it does intersect the y-axis. And then we need to figure out the slope. The slope is going to be the rise over run for the graph. And for my particular line of best fit, it kind of looks like it's going up 1 and over 3. But we do need to be mindful of the scale. When we go up 1, we're not actually going up 1 on the scale. On my graph, when I go up 1 unit, that actually represents 5 centimeters on the graph. So I'm going up 5 centimeters. When I go over 3, if I look down, that does actually represent 3 months on the graph. So the slope of my line of best fit is 5 over 3. The beginning point for me is a little bit above 55, so I would say the equation of this line could be y equals 5 over 3x plus 56. Now on the test, everyone's line of best fit that you draw in will be a little bit different, so everyone's slope will be a little bit different, and everyone's y-intercept will be a little bit different. But the equation you write should match the picture that you draw. So it says we were supposed to make a scatter plot, draw in the line of best fit, write the equation of the line, and then we want to know what the slope represents and what the y-intercept represents. The slope of that line is 5 over 3. And if we go back to the units on the graph, the 5 was 5 centimeters, and the 3 was 3 months. Those units can help us decide what the slope represents. What this means is that the height of the child is increasing because the line is going up 5 centimeters every 3 months. Another way to say that, if we actually do 5 divided by 3, that would be about 1.6 repeating, or exactly 1.6 repeating. So another way to say that is that the height is increasing 1.6 repeating centimeters every 1 month. Either of those answers would be okay, but both answers do relate to the situation and have the units that are in the story problem. The y-intercept. The y-intercept is 56. And if we look at what that represents in terms of the graph and the situation, the 56 was right here. It was 56 centimeters at 0 months. So this is saying that the beginning height was 56 centimeters, or that this child, or the average child, is about 56 centimeters when born. This is the height at 0 months or when the child is born. When you have questions that are asking you what the slope and the y-intercept represent in terms of the story, it's really helpful to look at the units. Looking at the slope as being 5 centimeters every 3 months, and looking at the y-intercept as being 56 centimeters at 0 months. Another topic on your test is arithmetic sequences, and we want to try to find a general rule for an arithmetic sequence, and then use that rule to come up with the 15th term. Pause the video and see if you can find a general rule and the 15th term for each of these two sequences, and start the video again when you have an answer. Remember, we had an equation. We said that the nth term of these sequences, which we represented as f of n, always equaled the first term plus n minus 1 times the common difference. We figured out that rule and the n minus 1 because we were always adding one less of whatever it was we were adding. When we were getting the first term, we weren't adding anything to it, and 0 is 1 less than 1. When we were getting the second term, we were starting with that first term and just adding, how much? 19 to it. And we're only adding 119. When we were getting the third term, it's really like we're starting at 72 and adding that 19 twice, which again is 1 less. So for these numbers, the nth term will be 72 plus 1 less 19 than whatever number you're looking for. We could leave the formula like that, or we could distribute and clean it up a little bit. We could say that the nth term is 72 plus 19n minus 19. And if we combine the like terms, we could say that the nth term is 19n plus 53. Now we can use that to figure out what the 15th term is. The 15th term we would represent as f of 15. So that would be 19 times 15 plus 53. So if we were to type that in on our calculator, 19 times 15 plus 53, we'll figure out what the 15th term of this pattern is. So if we type in 19 times 15 plus 53, we get a total of 338. The 15th term of this pattern is 338. The second sequence is presented in a little bit of a different way, but the same rules are going to apply. The first number is 9, and the common difference is -4. When the common difference is negative, make sure you put it in parentheses. Otherwise, the notation that you're writing is going to indicate -4 instead of multiplying by -4. If you distribute and combine like terms, the final answer you get for the nth term should be -4n plus 13. I skipped a few steps there, but hopefully you can do those steps on your own. If we want to use that rule to come up with the 15th term, we'll plug 15 in for n and find out that the 15th term of this sequence is -47. The last thing I want to review is finding the inverse of an equation. If the equation is written in function notation, remember f of x is just another way of writing y. So this original equation is y equals 2x minus 10. It has a slope of 2 and a y-intercept of -10. So we can graph it by beginning at -10 on the y-axis and then moving up 2 over 1. When you make your graphs on the test, make sure you plot all of the nice points on the graph. Connect the dots with a very straight line, and put arrows at the end. Pause the video while you catch up and make that original graph. Now that we have the original one graphed, let's find the inverse. To find the inverse, switch the x's and y's, and then solve the equation for the new y. In this case, that means we'll need to add 10 to both sides, and divide by 2. When we divide by 2, we're dividing everything by 2. So when we do x divided by 2, that's 1/2 x, and 10 divided by 2 is 5. Since the original equation was written in function notation, we want to write the inverse with function notation. And for inverse, we're going to write f negative 1 of x equals 1/2 x plus 5. If we graph that, the line has a slope of 1/2 and a y-intercept of positive 5. So we can begin at positive 5 on the y-axis and move up 1 over 2. The graph is a great way to check to make sure that your inverse equation is correct. The two lines should be a mirror image over the line y equals x. And if we look at those two lines, it does look like an exact flip over that diagonal line.